Hi everyone, in this video we're going to go through section 28.3 called the exponential form. We start out with a little bit of review of the exponential form. That is, the derivative of e to the x is, if you recall, this is a really tough one, e to the x. Whoa, okay. But it gets more complicated than that, right? When it's not just an x up in the exponent. The derivative of e to the 3x is e to the 3x, but we multiply by the derivative of the exponent, that's that chain rule, so times the 3 out in front. And then the derivative of e to the x cubed plus x is, of course, x cubed plus x, or e to the x cubed plus x, but that gets multiplied by 3x squared plus 1, the derivative of the exponent. Okay, so that leads us to the monumental, mind-blowing formula of this section, the exponential form. We're taking the integral of e to the x dx with respect to x, and that is, of course, e to the x, but don't forget to tack on, plus our constant c. We'll go through a few examples to practice this, and ultimately most of them will involve various U-substitution. So in this section, we get lots more practice with U-substitution. In this first problem here, we're going to set u equal to what's up in the exponent, x squared, and du is 2x dx. So inside of my integral, I have my x squared. That is u. I also have an x dx. I also have an x dx, but there's that extra 2 hanging out on the right, so we're going to divide by that. Whoops, and we'll write this as 1/2 du is equal to x dx. And there we have everything for our substitution. So after we substitute, we have the integral of 1/2 e to the u du. All right, that is 1/2 e to the u plus c, and then don't forget to back substitute 1/2 e raised to the x squared plus c. And you can kind of see how if you check it with a derivative, the derivative of x squared comes down, the 2 cancels out the 1/2 and leaves behind just the x that's up in the front at the beginning of the problem. Next example is a little bit more challenging because the first step is not as obvious. Before we do any u substitutions or anything, we have just an e to the 3x in the denominator, and it's hard to integrate when you have stuff in the numerator and the denominator unless you're doing a u substitution. But what we can do, since there's nothing else up in the numerator other than the dx, is we can bring that e to the 3x up and write it with a negative exponent. So that is the same thing as e to the negative 3x dx. And now I can take and set u equal to the numerator, or the exponent, excuse me. Du is negative 3 dx. So this is e to the u up there. Du is right there, kind of. There's the negative 3 again, but like in the last one, we can write that as negative 1/3 du, so divide by that negative 3 equals dx. And now I'm good to make my substitutions. Negative 1/3 e to the u du, which is negative 1/3 e to the negative 3x plus c. Okay, cool. Another example here, this one looks even crazier, but luckily I am here to guide you through it. What we're going to do in this integral is simplify first. Since we have e to the x's all over the place, 2 of them up in the numerator, we're going to take this fraction and do the division. And by that I mean I'm going to take this first term in the numerator divided by the denominator. And when I do that, the 4 divides by 1 in the denominator, leaves behind a 4. And the e to the 3x, the e to the x plus 1, when you're dividing, think like x to the 5th over x squared. That equals x cubed. When you're dividing, you subtract the exponents. So this is 4e to the, and I'll put it in parentheses, 3x minus x minus 1. So I'm subtracting the stuff in the exponent of the denominator. That's my new first term. And then my new second term is 3e, and then the exponent on that is x minus 1. right? I'm distributing the negative to both terms. So that whole big mess, which we'll simplify it before doing anything else, but that's what we're integrating. And let's see what it simplifies to. 4e, 3x minus x is 2x minus 1 minus 3e, x minus x is 0, negative 1 dx. All right, good progress here. Our next step, let's focus on just the second term. Start there. E to the negative 1 is a number, 3 is a number, that term is a constant. What do you get when you integrate a constant? A constant times x. The integral of 2 is 2x. The antiderivative of 3 is 3x. So this guy becomes 3 over e, the negative I'm just choosing to write in the denominator, times x. I'm going to write my plus c at the end, and now focus all of my attention on the first term. And if I wanted to, I could show this with a U-substitution. I could set u equal to 2x minus 1, and then du would be 2 dx. But I can kind of see ahead of time that I would have a 1/2 coming out of this. I know that the integral of e to the 2x minus 1 is e to the 2x minus 1, but as I've done this a few times now, I know that I'm going to get a over 2 from this part of the substitution. So if you can sometimes see that like coming from ahead of time, then you can make that jump if you're comfortable, if you get it correct. If you find that you're making more mistakes, that's not a good idea. When in doubt, show that full substitution. Okay, so then we'll finish this one off by writing our answer. 2e to the 2x minus 1 minus 3 over e times x plus a constant c. Okay, so that a little bit more challenging, that one. That's the problem where you're like, I hope he doesn't throw anything like that at me on the test. But you work through it in the homework or in the notes, and then you might see a homework question where you have to struggle through it too. In our last problem, we have a definite integral. Notice there are bounds on my integral, so I'm not going to have any plus c's. I'm going to substitute into this one. And what we can kind of see here is maybe the substitution is a little bit obvious, right? We have a sine theta and a cosine theta. The cosine's the one up in the numerator, so that's the one I'm going to set u equal to. Cosine 2 theta. Its derivative is negative 2 sine 2 theta d theta. The negative 2, it's negative because the derivative of cosine is negative sine, and the 2 comes from the chain rule. So my new integral is, well, just e to the u du. Well, plus there's a negative half there, so don't forget about that. Okay, so where did everything go? Cosine 2 theta in the exponent is u. Sine 2 theta d theta, sine 2 theta d theta is du, but I've got that negative 2 to deal with, and it comes into my integral as a negative 1/2. All right. The only other thing I have to focus on now is my bounds. The bottom bound is 0 in terms of theta. What is it in terms of u? So I'm going to jump over to the right here. So let's see. The cosine of 2 times 0, check that in your calculator. 2 times 0 is 0. Cosine of 0 is 1. So my bottom bound is now 1. And then the top bound, the cosine of 2 times half a pi, pi over 2, the cosine of pi is negative 1. So this looks a little bit funny that my bounds are backwards. It happens. There's nothing wrong with that. It's just the way that this U-substitution worked out. Don't change anything. It's okay to have the top number be negative, bottom number be positive. It's just, it doesn't happen often. All right, so now negative 1/2 tags along. The integral of e to the u, lo and behold, is e to the u. Substitute in my bounds. Top bound first, negative 1/2 times e to the negative 1 minus e to the positive 1. Okay, let's clean this up a little bit, make it look nicer. I'm going to distribute the negative 1/2, and that e to the first power, this e to the first power that's negative becomes positive, so I'm going to choose to write that first. E over 2, right? So I'm distributing here and writing that first because it's positive, and then when I distribute here, it's minus 1 over 2e. Hopefully you see that. The e drops down to the denominator, this guy, because it has a negative exponent. The 2 is also in the denominator, so 1 over 2e. We could write that as a single fraction if we wanted to. This is like extra work. I would be fine with this answer. I would be fine with this answer too. I'd prefer to see it a little bit simpler. But the best way is to get a common denominator and combine these two terms. So if I multiply the first fraction by e, it's e squared minus 1 over 2e. And no plus c, remember, because this was a definite integral we had bounds to substitute into. All right, that is the end of this video. We are very quickly approaching the end. Thank you very much for listening. Have a wonderful day.